In this lesson, Unit 5, Lesson 5, titled Molar Mass, our objective is that students will be able to calculate the molar mass of a substance, and the two vocabulary terms are mole and Avogadro's number. So the first thing we're going to talk about here is the term mole. And when you hear mole, I'm sure one of two things pops into your head. It could be this guy here, which I actually had no idea that their mouth looked like that. It's like, I don't know, it's kind of creepy to me, but you learn something new. So you probably think of that, or you might think of like a mole on somebody's face, like in Austin Powers here. But neither of those is the mole that I'm actually talking about. In chemistry, the mole, actually I'm going to bring up the definition here, which I want you to write down, and then we'll talk about it. A mole is a unit that is equal to 6.02 times 10 to the 23rd particles. Go ahead and write that definition down. And so let's talk about what that means. It's a unit, which means if you tell me you have 10 moles, that moles means something. It means that you're measuring something. All right? So what does it mean? It means that you are actually trying to tell me that there's a certain number of particles in that sample of matter. So, if I have 1 mole, let's say of a substance like water, you are telling me that I basically have that many particles. Okay, so I'm literally picturing like 6.02 times 10 to the 23rd particles. And I could sit here for my whole life and just try to draw all these dots that represent the particles, and I will not even be able to do it because 6.02 is such a huge number. If you're not sure what that means, 6.02 means you have the number 6.02, this is scientific notation, and you have to multiply it by 10 23 times. What we can do is that actually means move the decimal to the right 23 times. So we can do it twice right here and move it there. So that's 602. But now I have to move it 21 more times, which means I have to add 21 zeros. I'm sure I'm not even going to be able to fit it, but my point here is that you realize that that is a huge number. So if I tell you I have a mole of water, I want you to appreciate just how many particles of water that is. And it's really, a mole of water is probably like a cup of water. And obviously there's so much water in the world. So you can't really comprehend how many particles there are. So this picture is kind of nice because when you hear mole, I want you to picture the substance and then picture all of the particles that make it up. Okay, so the other thing I want to highlight is that we do this all the time, and when I say we do this, I mean we take a big number and turn it into one something, and we make up a new unit. All right, if you don't believe me, here we go. 12 eggs, eggs being the unit, is equal to 1 what? Hopefully you would tell me dozen. So dozen is a unit, just like a mole, that represents a larger number of things. Okay? Still don't quite get it? Let's try one more. 365 days is equal to 1 what? Of course you would say a year. So a year is a unit that represents a larger number of things. Just like a mole represents a large number of particles. So I want you right now to make sure you have the definition of mole and like a description of what it is, and maybe even one of my analogies here of days to years, eggs to dozen, or if you really want to challenge yourself here, make up a couple more of these instances where we take a large number and turn it into one something. All right? I know this was a long part, but I promise the rest of it is quicker. So the skill that we're going to be able to do after this lesson is we are going to be able to find the molar mass of a substance. So write this definition down. The molar mass is the mass of 1 mole of a substance. When I say 1 mole, I hope that you were just picturing a substance and you were picturing 6.02 times 10 to the 23rd particles. Okay, so picture like a handful of the substance that has that many particles in it. We are looking for the mass of that particular amount. Okay, the unit that you're going to use, because we're doing mass of 1 mole, the unit is grams per mole, and that's how you would say that. And I did not make a spelling mistake there. The abbreviation for mole is MOL. You still say it mole though. Now this goes against my instincts here, but I can't quite explain why molar mass is going to be useful to us without thoroughly confusing you a lot. So I'm going to ask you to trust me that we're going to use this, and I'm just going to ask you to get the skill down, okay? So do you trust me? I am sure that you said yes. Okay, so the good news is this is actually pretty simple because a lot of people did a lot of work for you in terms of molar mass. So if you're looking at the periodic table, and I zoomed in here so you could see it, the molar mass is as simple as the number right here. See this 1.007 for hydrogen? That is the molar mass of hydrogen. If you had 1 mole of this substance, this is how many grams it would weigh. Okay? Look down to lithium. If you had 1 mole of lithium, 6.02 times 10 to the 23rd particles, you would be weighing out 6.941 grams. Okay, so we can do this for any substance. Oops, moving everything around here. We can do that for any substance. Let's go over to the other side of the table here. Look at oxygen. If I asked you, please go get me 1 mole of oxygen, you're not going to count out the particles. You can't do it. They're too small, and it would take 80 bajillion lifetimes. Instead, you're going to weigh out 15.9994 grams, and that will give you 1 mole. Okay? So go ahead and write down how you find the molar mass of an element. And what you should be doing here is you should be like drawing one of these element squares, boxes here, and then circling and showing where to find that molar mass. A little bit of a harder skill, and it just takes a little bit more time, is to find the molar mass of a compound. So an element's easy, you just look at the periodic table. A compound is as simple as, if we have a compound like CO2, the molar mass of the compound is going to be the molar mass of all of its atoms added up. So what I have to do is find the molar mass of carbon. So there it is. So I'm going to say the molar mass of carbon is 12.01. I'm just going to keep 2 decimal places. And the molar mass of oxygen is right there. Okay? That's if I have 1 C and 1 O. But I don't. I have 1 C and 2 O's. So guess what I do? I multiply that by 2, and I know that 16 times 2, I'm going to round here to 32. Okay? So the carbon is contributing about 12 grams, and the oxygens are contributing 32. Guess what I do to get the whole big bad molar mass is I'm going to add these values up. 12.01 plus 32. Oh shoot, I ran out of room here, so I'm going to write it down here. Seems like it's going to be, I'm doing this in my head here, 44.01. And my unit, remember, is right up here, grams per mole. I want you to stop and think what that means. It means that if you had a mole of carbon dioxide gas, so go ahead and breathe into your hand, try to catch it. If you had exactly 1 mole in your hand, it would weigh 44.01 grams. Okay, so if you think you get it, I want you to try to find me the molar mass of H2O, water. So go ahead and pause me, try it, and then you can fast forward to the answer. If you didn't get the answer correct, rewind and listen to the explanation, all right? So spoiler alert here, I'm going to go over the answer right now. You're going to need a periodic table, by the way. So hydrogen, if you look on the periodic table, is 1.01, and oxygen is 16.00. Okay? I ask myself, well, that's the molar mass of one hydrogen, but I have 2 hydrogens, so some simple math tells me that's going to be 2.02. I only have 1 oxygen, so this is unnecessary, but if it makes you feel better, you can do times 1. And so if I want the mass of the whole compound, I'm going to have to add these up to get 18.02. I take care to make sure I put grams per mole. So I'm thinking in my head, if I had a mole of water, 6.02 times 10 to the 23rd particles of this, it would weigh 18.02 grams.